Hi, welcome back. This is part 3 of chapter E. And in this part we're going to look at those significant figures that we've been able to identify after our work with part 2, and we're going to use those in calculations and then make sure that our numbers have the right significant figures. So when we're doing these measurements in a laboratory, for example, one of the common things to do is to measure volume in a graduated cylinder. And so if you'll notice that because of some of the properties of water, it tends to kind of hang on with surface tension and make a little smile, okay? And so we call that the meniscus. And so to be consistent, we measure the volume at the bottom of that meniscus every single time, okay? And so when we're making a measurement, we're going to look at this. Notice that the 4 is here and the 5 is there. So when I'm deciding the number that I'm going to record, I know that it is greater than 4, but it's not quite 5 yet. So the first number will be a 4, all right? There are 10 tick marks in between the 4 and the 5. So that's going to be my decimal place. So then I look at where this meniscus is, and these that stick out a little further are 0.5. And so it's a little more than 0.5, but it's not quite 0.6. So my next number is going to be the 5. Now this last one, this is where the uncertainty comes from. I have to make a judgment call as to where I think that is, okay? And it just depends on how you look at it, because I know it's between 4.5 and 4.6, but I don't have a line, okay? And so it depends on what your eyes say. My eyes say it's a little bit farther than halfway, so I'm going to call it 4.56. Notice that this is our uncertainty reading, okay? And so we have to make our best guess as to what that is. And so I can report 3 significant figures in this measurement. Okay, so 4.56 is milliliters is what I'm saying that is. In scientific notation, if you recall, you're going to take where your decimal would be and you're going to go backwards if it's a big number, okay? And that, since that was a placeholder, you're only going to express that 3.01 times 10 to the third, okay? Because we went three spaces to the left there. Just remember that it's going to be a positive exponent if it's a big number, and it's going to be a negative exponent if it's a small number. So in the case of 0.0310, we're going to have, that's a placeholder, right? So we're going to have 3.10 times 10 to the minus 2. That's 3 significant figures as well. So both of those had 3 significant figures. And a lot of times if you put it in scientific notation, it'll kind of show you, because obviously you're not going to say 03.10, right, for your scientific notation, and that tells you that leading 0 is not significant. So when we perform mathematical operations, such as multiplying, dividing, adding, and subtracting, we can only be as precise as our least precise measurement. So our answer can only have the number of significant figures of our least number of significant figures. And so what I mean is, because if I have 2 numbers, one has 2 significant figures, one has 3, and I'm adding them together, my answer can only have 2. Okay? All right, so there's different rules depending on if I'm multiplying, dividing, or if I'm adding and subtracting. So when I'm multiplying and dividing, it's going to be the number of significant figures. Okay, so in this particular case, I look at these and I say, okay, that's got 3. That's only got 1. So my answer, even though that's what my calculator tells me, my answer can only have 1 significant figure. And so that would give me actually 10, because my least number of significant figures was 1, and so I can only be as precise as to tell you that it's 10. 2.050 has 4 significant figures times 5.0, which has 2. So my answer is going to have 2. So my answer there is also going to be what? 10, but it's going to be 10.0 or 1.0 times 10 to the first. Because this number is significant, because in this case I'm reporting that number to 2 significant figures. If I just put 10 there, that would only be 1, right? Like this one was. So I have to put that decimal there, or I can put it in scientific notation to show you that it's got 2 significant figures. Don't forget that you can rewind me and re-listen to things if you don't quite catch something. So alright, so we've got 3 significant figures in this number, and I've got 1 significant figure in this number, so my answer can only have 1 significant figure, therefore that's going to be 5. Now this one, I've got all kinds of crazy stuff going on. I've got 4.5 feet, notice. Then I've got all of these equalities. 12 inches over 1 foot. 2.54 centimeters divided by 1 inch, and 1 meter divided by 100 centimeters. Those are all equalities, right? We're going to talk about those a lot more at the end. And equalities mean that they have an infinite or unlimited number of SFs. So the only thing that I'm going to be worried about is my measurement, okay? In this case, I'm converting my feet to meters. And so my measurement, my calculator ends up with 1.3716 meters. But since I only had 2 significant figures, which is going to be the least number because the others are unlimited, my answer can only have 2, so that would be 1.4 meters. Now, that was multiplying and dividing, and you use the lowest number of significant figures. When you add and subtract, you're going to use the lowest number of decimal places. The lowest number of decimal places. So if you've got 23.467, that has 3. You've got 313.21, that has 2 decimal places. So your answer can only have 2 decimal places. So I'm going to have to round that up to 336.68. Okay, because it has 2 decimal places. In the second example, I've got 0 decimal places, 2 decimal places, so my answer can only have 0 decimal places, and so that's going to give me 456. Alright, so here's some examples that you can put in your calculator and make sure that you're getting these numbers. Alright, the first one, you got 1.10 times 0.5120 times 4.0015 divided by 3.455. Now when you put that into your calculator, you should get 0.65219. Now I've got to make sure that I do that in the correct number of significant figures. So I've got 3 here, I've got 4 here, and I've got 5 here, and then I've got 5 here. So the lowest number of significant figures was 3, so that's how many I have in my answer. So 0.65, and this one remains a 2 because the next number was a 1. So if it's 5 or greater, you round up. And if it's less than 5 in the next number, you round down. Should probably remember those rounding rules. Okay, and then the next one 0.355. So that's got, now this is adding and subtracting. So we're going to use decimal places for this one. So that's got 3, that's got 1, that's got 4. So our answer when we put it in the calculator, 4.8, oops, sorry about that, 4.873. Oh, let me go back. There we go. 4.8730. All right, and I can only have one decimal place, so my answer is going to be 4.9. This next one is multiplying and dividing. Okay, so notice that I've got some things in parentheses, and if you remember the order of operations, you're going to do what's in parentheses first. All right, and then if you've got exponents, you're going to do those, and then you're going to multiply, and then you're going to divide, and then you're going to add. So I'm going to do this first. This is really important that you do this in the correct order of operations in your calculator. So I would do this first and get this number, okay? And then you're going to say 4.562 times 3.99870 divided by whatever this number was, okay? Divided by that number. Now you've got to, when you're doing mixes here, when you've got adding and subtracting and multiplying or dividing, then you've got to kind of keep up with what you would get. When you subtract these two numbers, you're going to have something with two decimal places. Okay, so two decimal places in your answer is going to end up with two significant figures. Do it in your calculator and you'll see what I'm talking about. Okay, and so then you've got this one, and so once you've done that, this had two significant figures, this product here. So then this one has 4, this one has 6, this one only had 2, so your answer is going to have 2. So instead of 52.79904, the answer is going to be 53 because you can only have two significant figures. All right. In this one, your multiplication is in your parentheses first. So you're going to have to do that number first. And I'll show you, I got 8.162. All right, for that one. Now, here's the deal. When I did this, two significant figures is all I could really report that as, right? So two significant figures. But the way this TRO textbook does for some of your homework and all that stuff is you leave all your numbers in there. So the 8.162 minus 8.02, I don't change that until the end, but I do have to remember that this one only had two significant figures from the product of the 14.84 times 0.55, and so I subtract those two and I get 8.162, no, sorry, 0.142. All right, so I'm subtracting now. So if this one only had two significant figures, that means it would have been 8.2, right? So that means that if I'm doing something with two significant figures or one decimal place minus 8.02 and I get 0.142, my answer can only have one decimal place because the last thing I'm doing is subtracting. So my answer would be 0.1, no 0. Okay, so 0.1. 0.1. Okay, so you can only have one significant figure because of that decimal place. So you keep this in your calculator, but you got to remember that it's really 8.2 because that's the, when you do that, because it could only have the one decimal place. right? Isn't this fun? All right, so here are your calculations that you're going to do for practice. And that is it for using calculations and making sure that you get the right number of significant figures.